All right, with that painful, very long first lecture out of the way, I'm going to go ahead and work through these pretty quickly. So, first thing I'm going to do is I'm going to switch my color to purple so we can separate my old work. Well, I can clear it as well too. I'll clear it so it's not as ugly. And I'm going to work in purple right now. So, here we go. When you solve any equation, the goal is to get the x by itself and everything else on the other side. X, variable, letter, whatever language we're using today, to get x by itself and then everything else on the other side. So at this point, most of us have this down. When I have an any number plus 6, to remove that 6 from one side, I'm going to subtract it. That's the opposite. And I'm going to do it on the other side as well too. That's the rule. Whatever I do on one side, I do on the other side. So this cancels out with each other. 0 minus 6 is negative 6. And I end up with 3x to the 1/2 as my thing. Now check it out. Now I'm kind of stuck here. Do you see how this 1/2 is now in the way? It's everything else is stuck in the parentheses. I have to get rid of this 1/2. How do I get rid of this 1/2? Well, it's kind of easy. We're going to do the reciprocal. We're going to raise this up to the power of 2. I'm out of room. Hold on one second. I'm going to push pause and fix this. All right. Change a little bit. Sorry for that. I was just looking ugly. I don't even know if I made enough space either, but we'll try it again. I'm going to raise this entire thing to the reciprocal. What is the reciprocal? You flip the fraction upside down. So in this case, it'll be 2 over 1. And now we know that's technically just raising it to the power of 2, but that's fine. And I can prove it to you. If I said 1/2 times 2 over 1, that ends up being 2 over 2, which reduces down to 1. So, but what's the rule here? If I do something on one side, I must what? Do it to the entire other side. So I'm going to go ahead and rewrite in purple again. What ends up happening is this 1/2 and this 2 over 1 cancels out. The parentheses are removed. This 3x is now freed up to go to the next level. Negative 6 raised to the power of 2. Negative 6 raised to the power of 2, y'all. That's just negative 6 squared. That's just negative 6 squared. So that's just negative 6 times negative 6, which gives you positive 36. So 3x equals 36. Now, this says 3 times x. Do the opposite, which is division. I'm going to divide this out on both sides. X equals 12. Now, you need to go back and plug this in, and I recommend going and using Desmos to do that. To check your work, genuinely plug it in. It's the fastest way, and make sure that it comes out correctly. So if you were to plug this into Desmos, this 12, I had to fix this little video. So if you were to plug this 12 into Desmos, you can see right here, check out what happens. I entered this equation in with my 3. Originally, I had an x right here. You can see how I did this. 3x raised to the power of half plus 1 plus 6. And on the notes, it says it has to equal to 0. If I found my answer as 12 and I plug it in, it has to equal to 0. But look what happens. It comes out as 12. So when I plug in a 12, I get a 12. If I plugged in a 12, I'm supposed to be getting a 0. So what ends up happening, what does that mean? That means this thing right here is extraneous. This is an extraneous solution. And if you don't want to be in charge of spelling extraneous, I recommend writing extra and putting a period there. Extra, that means it's abbreviation, extraneous solution. That is how you do it. Make sure that period's there, extraneous. That's that. That's how you do those things. So I'm going to now finish modeling the other problems. And I'm going to go a little quicker on the other ones.